Alright guys, thank you for staying until the end. You're the best. So this talk is about hunting down botnets using network intelligence and mostly network traffic analysis and network artifacts. So about me, my name's Thomas. I don't know how to pronounce my last name in English. If you find a nice way, then just tell me because it's horrible. Anyways, I'm an incident handler at CERF, Société Générale, which is a banking cert, one of the biggest banks in France. I mostly do digital forensics, incident response, also known as EFIR. Also some malware analysis, although my assembly skills are not that good. And I recently integrated a hunting project, especially to work on what I'm going to present today. I tweet, I blog sometimes, and also we're hiring, so if you're in France and you're looking for a job and you like digital forensics, incident response, malware analysis, then just come talk to me and maybe you can get a job. So this talk is going to be about common IR problems that every incident handler finds every day and needs to resolve. It's also going to be about what is Malcolm, which is a tool I've developed, and how it leverages network traffic analysis and artifacts, and also open source intelligence to solve the aforementioned problems. We're going to have some demos on Malcolm versus botnets. I'm also going to talk a little bit about how you can use Malcolm to deal with these problems like customization and everything, and also how you can help Malcolm grow a little bigger. So yeah, I'm an incident handler, so I have lots of problems. How many incident handlers are in the room? Okay, so I guess you guys have lots of problems also, most of the time. The first problem is malware, banking malware. I just want to kill the malware, and I'm sure the guys from Malware Must Die are going to agree with me. I mean, come on, banking malware is a pain, and they're encrypting everything today, so it's even worse than APT malware, I guess. Anyway, so what do I need to be able to kill the malware and take down and, deal with this? I need to enumerate domain names and IP addresses the malwares are using to communicate. I need to identify resources like gates, for just drop zones, configuration areas, servers, etc. And also I need to gather the data that the malware sends, like, I don't know, stolen data, configuration files, know who is affected, if we're affected, etc. I need to do this so I can, well, first alert the owners of the data so that they can have their measures. I need to send takedown requests because, well, in a cert, and I'll be talking about this, but we don't really have time to dig deep as the guy from Malware Must Die or others have done to just take down a single whole botnet. I'd also like to build threat intelligence so I can refer to it later, say, oh, well, I've already seen this like 2 months ago, but of course, domain name, 15 characters, I'll never remember it. And also, I want to start incident remediation. Like, okay, what do I have to do in order to avoid this to happen in the future? The second problem I have is that, well, when we receive malware, we're not sure if it's like really, really critical malware or if it's just another strain of Zeus or Citadel or something that may or may not drop something more important like, I don't know, CryptoLocker, which could be a really big threat. So what can I do? I can do an antivirus scan on it and get like Trojan, generic, suspicious malware, which won't get me really far. Thank you, AV vendors, for not agreeing on common names. But I could also reverse engineer it, but, well, my assembly is really bad. And I receive 3 samples a day, so I really don't have time. Okay, obviously, what I end up doing is running in a sandbox and do some behavioral analysis, like, okay, where is it dropping itself? What is it dropping? Where is it installing itself? You know, Zeus and Citadel and stuff, they have really common patterns, so it's pretty easy to identify. But I also try to cross-reference network artifacts, against public blacklist like Zeus Tracker or malware, WU, stuff like that. My third problem, I'm an incident responder, so I really have to do this fast. I have tons of requests coming in, and most of the time, not really important, but still, you have to deal with them. So I don't want to start Wireshark, my text editor, gedit, snort, TCP flow, foremost to carve files, etc. I want something fast that can help me really well. I want just to drop my malware in a VM and quickly know its behavior. So we already have tools for that, like, for example, Cuckoo Sandbox. The peers it has, so I can just send a takedown request easily. And also, once I've done that, I like to keep the data and information in one place, one centralized place, so I can react faster next time. So, well, you probably guessed it, Malcolm helps solve most of these problems. Maybe not entirely, but, well, what is Malcolm? Malcolm is Malware Communications Analyzer. It's not like the name, because there's an L missing. So for those who ask, who is Malcolm? No, I'm sorry, he's not going to be here today. It's available on GitHub. It's completely open source. I want to share it with everybody. So basically, it combines threat intelligence and malware analysis. So it leverages both worlds to make actions faster. I can gather intelligence on network artifacts by basically siphoning the whole internet. So I don't use sinkholes for that, but I use processes that are going to check mostly blacklists, public lists, etc., in order to get domain names, URLs, IPs, analyze them, correlate them, and build a solid base of intel information. And at the same time, it will match that intelligence with whatever artifacts the malware is generating. The aim is to identify the targets for my takedown requests or abuse requests, draw conclusions, okay, is this important, is this not important, and act fast. Just one slide on architecture. It's built with Python, Scapy, which probably is going to change thanks to Sebastian, which is working on it. Also MongoDB, which is a big data, buzzword, big data and front end. The good thing about Mongo is that we can, there's no schema. So it's a good thing, it's a bad thing. It's a good thing because, you know, I can add fields and I don't have to migrate my whole database. But it's also really messy, especially for someone like me. I also use Flask, which is kind of like Django, but really, really lighter. Only deals with web requests and a template engine, so I can have a web frontend. Bootstrap, because, you know, HTML. And D3GS, which is a graphing library in JavaScript. Basically, Malcolm is meant to be virtualized. It has 3 modules, one analytics and correlation engine, which will grab data from its database and just resolve domain names, A records, MX records, NS records, resolve the NS records. It will take a URL, get the domain, get the path, get the sheen. For an IP, it will get the geolocation, VAS, etc. It also has a feeding engine, which until some while ago was like one process spawning a bunch of threads. Thanks to Pete, I don't know if he's here, taking pictures. No, you're not. Oh, there he is. Thanks to him, well, now we have a celery engine, which basically consumed 100% of my processor in my VM. So I'm just leaving that for the servers. And also, well, a web interface, so I can use it quite easily. It works with elements, so every data gathered from the feeds are elements. You have domains, you have host names, sorry, you have IPs, you have URLs. We'll see that later, but you can have basically whatever you want. And each element has one function, which is its analysis function. So from that element, it will derive other elements. For example, for a domain or a host name, you'll have A records, NS records, MX records, etc. Every element is tagged according to some of its context. It can be malware, Zeus, it can also be your source, it can also be internal, external, etc. The one thing I had in mind was I want to use something that really makes me not lose time and quickly yield actionable intelligence. So if I see a malware communicating somewhere and I don't want to spend my day looking in blacklists to see where it came from. I just want to know really quick that this comes from this record, abuse.ch, something. Sure, other techniques like reverse engineering, fuzzy hashing, etc. may lead to more accurate and complete information, but I don't have enough time, and sometimes it's true that it's more important to neutralize the threats than to know exactly what it is. When you reach the knowledge that, well, the threat is not critical and it's not an APT or whatever. And also, well, I wanted something visual and nice to look at. So Malcolm helps me with the recurring tasks. Emails I receive, is this IP, URL, domain, something we should worry about? Well, the OSINT lint for search for artifacts is done automatically. I just type my domain and it will automatically check on the list it has. It will gather all the internet badness in one single area, so search is really fast. It's easy to query. There's a nice web interface, WebSockets, which most of the time work. It's easy to hop from artifact to artifact. So for example, if I have an IP address and I don't have a related domain, I can just query for the IP address. And if Malcolm, during his lifetime, has ever seen the domain being mapped to this IP, then I'll know that the domain is that one. And inversely, if I have a domain mapping to one IP, then I can know which others IP have been or are still related to the domain. Second recurring task. I received the following 0-day APT attachments. Is it malicious? Well, yeah, most of the time it follows by, oh yeah, here are the VirusTotal results for the upload. So, well, there goes your OPSEC, right? If you didn't want to be discovered. Anyways, yes, no, maybe, I don't know. Just throw it in a sandbox and see what it does. If you guys do this often, and I'm sure you do, because like me, maybe you don't have that much time, you probably already have a sandbox with all the tools. And that's okay, because you can just put Malcolm between your sandbox, virtual, physical, whatever, and the internet. Because I really wanted to keep Malcolm as agnostic as it could be. So for example, you could put in front of a cuckoo, and then you could have both analysis, network analysis from Malcolm and then cuckoo for all what system and system calls, etc. Recurring task number 3. Okay, so now I have a bunch of domains, and I have a bunch of email addresses, and I want to know who do I have to send this abuse email to. Have you guys ever used Wireshark to list DNS requests? And it's really hard to map every request to every response and easily see which IP addresses they yield, etc. So at least now you know which are the domains you have to take down. You'll see the host communication be graphed in real time. You can also store them for later use or replay in a pickup form, or even if you want to put them in another tool that you trust more or you're more used to, then yeah, no problem, you can do that. You'll instantly know what kind of botnet you're dealing with. If it's one or many CNCs, if you have a P2P network, a fast plug architecture, or DGAs. We're going to see that in a moment. And finally, you can also cross-reference all these artifacts with stuff you already know. So if someone you know, or if you know, if you've already seen that stuff, then you'll know it instantly. We're going to see about data sharing later. So, demo time. Fingers crossed. Oh, it's going to be videos, so I really hope my codecs are working. Anyways, here we go. So, for CNC servers, first we had IRC, then we had HTTP. So usually what you get with this kind of stuff is first a ping to check for internet connectivity, then fetch a configuration file from a central CNC server, and maybe dump the data somewhere else, or something like that. I'm going to try something really scary. Okay. There we go. Aw, man. That's okay. So this is the Malcolm interface. You have the data set. I'm not going to spend a lot of time with this, but data set lists all the data you have. The sniffer module is the one that will either sniff your network communications or load a pcap file. So, of course, for demo purposes, it will load a pcap file. So this is basically a pony that's going to drop this malware. So you can see the things are being graphed in real time. So in fact, I did video so I could pause and explain a little bit what's happening here. This is your central host, and it's communicating outwards. Here, I don't know if you guys can see really well. There's a URL being requested. See ponygates.php. There you go. That's another URL. So there you see all the flows, the connections. You can see HTTP requests, the responses. It's downloading something quite big. There's a request towards gate. You can see the response right here, which is of course encrypted because these guys, they don't like us. And well, the response. Look at the headers. MZ, this program must be run under Windows 32. So there you have your malicious payload. In the latest versions, you can just download the raw payload and just push that to VirusTotal, or the hash VirusTotal, if you mind your privacy. Anyway, so that's most of it, I guess, for this one. Yep. Back to our error page. So, what kind of countermeasures do we have? We can quickly identify the malicious hosts. You saw them. They were both URLs and their hosts. Well, is it a strange domain name? Is it using non-standard encryption? Anything that goes through 480 and is basically unreadable, I guess that would raise flags. Are there weird file transfers like an exe file? Strange 509 certificates? Well, some of these features Malcolm will tell you in the future when I have time to develop them, but I mean, the idea is there. It's to be able to gain information really fast. Or to dig into the database, we can... Okay, this is working. So, for example, I have this URL here, which is connected to this malware. I guess this is not working because the analysis aren't done yet, but I take like... I really hope this is going to work. This is a live demo, it's not a video. And it's like, while it's searching, I can continue with this. So anyways, this will let you dig into stuff and branch out every node that you have to see if oh, this is not working. Definitely. Okay. Never mind. I'll try and show you later with some other examples. Fluxing, domain flux. So domain generation algorithms. I have the example of CryptoLocker to show you. CryptoLocker works basically by requesting, where'd it go? It has a DGA, so basically, according to the data, we generate a couple of thousand domains. There was actually a strategic choice to make this a video because most of the domains are sinkhole nowadays, and usually 1 or 2 per day are active CryptoLocker domains. So when I first tried doing this demo, I waited for like 10 minutes until CryptoLocker could find its host. So here I cheated, I already started, and you can see these are the host names, which are not mapping to anything. So they've not been registered. These, on the other hand, are domains which match exactly a sinkhole from DNS Sync. I don't know if you can see really well. I promise it's way better when you see it in the screen. It's going to take a while. This is my host. This is my SyncDNS IP. And these are all the domains that are connected. So that's a really good way to see which domains have been sinkholed, and also who is sinkholing all the domains. So you see that the other they just pop up because they're being requested. This comes actually from a live sniffing session, because there was no pickup. It should come up over here any moment now. Faster. There it is. Here you have it. This domain, this is a guy. This URL /home, which is where CryptoLocker requests its DNS, its public key information. This is the IP. So we just look at it here. You can see all the failed attempts to contact the sinkholes. There's a request. And the response. And there go your Word documents. And I really hope you're not connected to a NAS or whatever, because you're going to have trouble. So, That was for the domain flux. So flux, basically, I understand it as a change. In order to preserve performance and resilience, the malware will, they will always try to change and try to avoid people from stopping them. So we've seen a couple of talks about single and double fast flux. So I guess everyone knows what it is. So single fast flux is on the domains A records, and double fast flux is on the domain A records, and also name server records. Sorry. So basically, I don't know if you ever tried to do this with Wireshark, but I could never read anything correctly. So there we go. This is from a PCAP. So you should know, full disclosure, the fast flux domains were a script I did, so I had to simulate them because I couldn't find any host that actually was working. So there they are. One request to tomtrap.me will yield tens of A records with a really low TTL. I'm not displaying the TTL, but soon, yes, in a future version. So once you clear the thing, you can see that the host is trying to contact each time an IP. And that's really useful because when you have several domain names that can be queried with fastflux, then you can know which IPs you have to take down. And since every time you start a capture, it will do a PCAP and store all these IPs and everything into the database, then it's really easy to query, okay, I want to know every IP that has been contacted by this fastflux algorithm or domain. And you can get those and send them to whoever's responsible for blocking them in your ISP or in your company. That's for the single fastflux. And the double fastflux, which is really similar, but you see the difference. Okay, so we have the same situation. We have this host. Here we have the NS servers that are linked to the host, and the IPs that are being contacted. So once you sort everything out, and you put the NS, you align them properly, and nothing happens for a while until the TTL expires, right? And suddenly, boom. The TTL expires, and then you have more domain names, which some of them map to the same IPs, and others don't. So you let this run for a while, and then you can see, or even you can script them and have a script that requests every domain and the A records and the NS records, and see when they expire. Get the IP list and send everything to your domain admins. Peer-to-peer. Well, that's a problem because it's very resilient. There's no real single point of failure. If you want to take these down, usually you have to crack whatever protocol they're using. Sometimes you can, and I guess some guys did that for the new Zeus variants, but usually adapt really fast, and they come back and they patch their stuff. There's not much Malcolm can do besides giving the initials peers IP addresses and eventually pinpoint the fallback CNC that the malware uses when it can't contact the host. So I don't know if you've heard, but there was a compromise from php.net. They were hosting malicious code that dropped a zero access. So I used Malcolm to graph the attack, so that's a really nice case. And see if I can show it to you. I guess it's this one. I hope it is. Yes. So it starts with a normal browsing session. You see php.net, URL, domain, IP, everything's linked. You have the static files. Inside one of those is the malicious JavaScript code that will load something from here. This domain is also quite strange. Z, Y, etc., 3, RAZ. Well, this is suspicious, definitely. So what's up with the flows? Let's see if we can identify the malicious JavaScript. These are requests to CSS and PNPs. Whoops. There it is. It's obfuscated. Well, of course, non-printable characters are non-printable. And here's the obfuscated JavaScript that will load everything. So one of the roadmaps, one of the elements in the roadmaps is to add some kind of rules that you can apply to every flow, and it will tell you automatically if it already knows them or not. So here are all the URLs that have been requested. You see there's a ton of those going to these domains. There's one here. There's also here, and that's really interesting because you see the HTTP requests, they are not using the domain anymore. They're using the IP, so these are mapped directly to the IP. And if you ever see this IP come up in your logs, then you'll be able to retrace back and see, oh, this is the same IP that's been used in the PHP compromise. Probably should do something about it. And then you can see all the hosts that this central host is trying to reach. Well, that's the peer-to-peer Zeus or zero axis you have. These are the reverse IPs, so you can see mostly resident. Well, maybe you can see. I don't know if you can see residential DSL lines from all over the world. You have Argentina, you have Turkey, you have Russia, Germany, .NET. That's for the nice graphic part. So, well, why should you guys try it out? It's really easy to customize. So today there's tons of feeds. I have sources which go from I have like 20 sources that Yom, I don't know if he's here or if he's already left, but Guillaume Martas, he helped me program them. So it can be internal sources from your company or whatever, community sources from closed groups, or also external data like public data or even blogs. You can scour blogs for IP addresses. It's really easy to create a feed because all you need is a few lines of Python code. If your Python code can read logs, then you can get some feeds. If you can read URLs, if you can read XML, if you can read binary protocols, then everything you can do with Python, you can add as a feed. So it's really flexible. Every element has individual refresh rates. So host names will refresh faster than IPs, for example. But if there's like one host name you really want to keep an eye on, then you can use refresh rates. That's really fast. So you can get really up-to-date information. It's really also easy to add element types like emails, which are not present already yet, sorry. But for example, if you do a domain, you can do a whois on the domain, get email addresses, and check email addresses like, okay, what other domains has this email address registered? And it kind of acts like a passive DNS. Well, also for domain names, but for email addresses, which is pretty cool. And well, sharing is caring. Share incident data. We who always deal with incidents, we know how valuable it is to share that kind of stuff. So I really wanted to make Malcolm, make it also a potential source for other people to gather information from. So there's a JSON feed for now. Maybe more formats will come soon. There's an API key that you would distribute to anybody you wanted to give access to that is mapped to certain tags. So for example, if you have a tag that says public and you can distribute an API key, okay, and you can say, okay, this API key is for things that are tagged public, I don't know, TLP green, TLP amber, whatever, you choose. If I still have 5 minutes left, great. So the roadmap, Yara rules in the flows payload. That would be really cool. You could identify not having to click like we did before in every flow, but just see, okay, this flow has an executable, this flow has an obflet, I don't know, exploits. Whatever you can code, I mean, I think the Yara community is going to get really big, and it will be nice to recycle and not reinvent the wheel. Also, is the application layer identified? Is it HTTP? Is it FTP? Just get the payload. I just want to click and get my malicious executable. I don't want to spend my time decoding, gzipping, or chunk encoding my communications. Also, it could be cool. Why not compare communication patterns with known patterns? Okay, Citadel sends a 64 bytes. I'm doing arbitrary here, but imagine there's a hello packet and then there's a response from the server, like for example CryptoLocker, who sends always the same kind of data. Then you could completely map this. Okay, this might be CryptoLocker. It's sending this and it's receiving this from the server. I'm sure BroIDS or Suricata have already nice rules for this, so I really like to integrate them. And also pick up two bubbles, which was an idea of Sébastien and Guillaume, which was like a web service where you could send your PCAPs and it would give you back the graph, which you could store and import into your own Malcolm for further study, or you could explore a data set, the data set of that server. We have kind of a function in service, which is in really, really early beta. It's not multi-user, so you can imagine the kind of waiting times you have. But as soon as it is, I'll be sure to post it. Also in the backend, well, I want to make it a little less hacky, like work on UI to add rules, Yara rules, to add feeds instead of having to dig in the code, maybe to change elements, values, or add comments to elements, make it really nice. I'd also like Redis to synchronize processes between the feeds, the analytics, and the web interface, so I can update the user as soon as it happens. And also, well, some performance improvements are in the scope because we're dealing with a lot of data and graphs, which are really tightly connected. So if you request, for example, to see all the neighbors of one of the big autonomous systems in France, like OVH, which is really malicious, then you'll get a really high overload. But all this is going to hopefully get fixed soon. If you want to help, you can help. It's open source, so pull requests are welcome. If you're a Python or a Flask enthusiast, if you're a MongoDB enthusiast, because I just put this in the DB, I discovered indexes like 1 month ago, so that really changed a lot. If you like WebSockets, or D3, God. If you're a D3 enthusiast, I'll pay you. I don't know, but please, please. If you've ever used D3 and really know how to use it, then you could really help, because for now I think the code works, but it could use some improvements. Just poke around. Remember, the dev branch has way more features. The master branch is the most stable branch, but the dev branch has way, way more features. Well, that's it. Got any questions?
Okay, we've finished on a nice tool to share and exchange. Yeah. Hi, Tom. This is Tom.
Upset.
Yes. I see a lot of similarities that the collective intelligence framework is doing.
Yep.
Have you thought about combining those two together and just build upon each other, or you're just like pulling feeds and using API keys for different TLP levels? And have you tried combining those two together?
I haven't tried combining them, but I did use Sif for a while, and I found it kind of hard to maintain, and it was written in Perl, so basically for me it wasn't readable. But I wanted to try to make, well, to combine the power of an idea like Sif with a nice user interface, and also the malware analysis part. So like really mix both. That being said, I know Sif is a great tool and does everything Malcolm does for the threat intel parts. I mean, there's a lot of people working on it. It's a really nice project, and I think Malcolm could, feed on Sif, and also inversely. So I think both tools are really complementary.
Yeah.
And also Sif has a really linear way to display stuff. So it would be really nice to have, you could have a Malcolm instance with only one feed, feeding off your Sif, and displaying the data in a graphical way. That'd be really cool.
Yes. What about HTTPS traffic? I've seen a lot of downloaders recently, Upatra using HTTPS. Can you see that traffic, or?
Yeah. During the last weeks, I implemented a TLS, breaking TLS, just like the NSA, but with my own certificates, so that was easy. There is a TLS proxy. Yeah.
Okay.
So I
good.
can see HTTPS communications.
Yeah.
It was one of the biggest requests I had from my colleagues. Like, why HTTPS? Please, let me see through it. Yeah.
Yeah. Great presentation. Great stuff. Yeah.
Thanks.
Thank you.
Thanks.
Other questions?
Sure. Hi, Tom. As Tom said, this is a great presentation, a great tool, and really nice to have such tools for our community. Now, something we have discussed a few weeks ago together about the possibility of retrieving, like a chunked, no, not chunked, but basically when you have like an exploit or a dropper,
Yep.
that would like fetch a payload, which is like XORed, obfuscated, and you have like the key somewhere in the stream. And you don't know how to fetch it basically, because when you have such payload, it's there, but you can see because it looks to you like a garbage. So you have to find the XOR key, XOR it, and find it out. So have you made any advance in that?
I thought of something. I remember our conversation. At the time, I remember we said, okay, I get the XOR thing, I just send it to my malware analyst, and he's going to work on it for 48 hours straight with coffee, and he's going to give me back the unXOR malware. Well, why not use his efforts? And as soon as I come across a similar thing that communicates in the same way, then I say, hey, you remember 3 months ago? You spent 48 hours and you found me a XOR key. Let's try and use it again. So that's why it's also important, because, well, the chances are really slim that you can fall on the same kind of sample with the same key, I don't know, 2 weeks apart or 1 month apart. But if people start sharing keys, then I can say, okay, I have like, I don't know, 1,000 keys I can try. And maybe, just maybe one of those will work, and I'll save my malware analyst like 48 hours. So that's the kind of way I see approaching things. I don't know if it's a good idea, but
Thank you.
welcome.